Hello everyone. Today we're going to be factoring and it is a difference of two squares. So I want you to remember back to last week when we were multiplying binomials times binomials. We had problems like this, 2x plus 5 times 2x minus 5. Now when we distributed these, we would get a 4x squared, a negative 10x, then a positive 10x, and a negative 25. Now what happened with the middle terms is they added to 0, so we only ended up with two terms. These are the type of problems we're going to be dealing with today. If you look at the original problem, the first terms are the same, so they both start off with a 2x. The second terms are both 5s. The only difference is that one of them is a plus and one of them is a minus. All of the answers for today's difference of two squares are gonna have the same structure. They're essentially the same binomial, but one's a plus and one's a minus. Now again, we're gonna start off with what is essentially the answer. So we're only gonna have two terms today, which is why it's 2. And if you look at the numbers, they're both square numbers, which is why it's a square, because 4 is 2 squared and 25 is 5 squared. They are also a difference because the problem is a subtraction. So like the name actually says what it is. It's a difference, which is a subtraction problem, of two squares. There are two of them and there are square numbers, okay? So on our factoring flowchart, which hopefully you either printed or copied down, we have done the GCF. We are still going to be using the GCF today. Sometimes we are going to factor it out, sometimes we are not. And today, when we ask the question of how many terms are there, the answer is going to be 2. And the only option for factoring for what we're working on today is it a difference of two squares? So the way this works is you're trying to figure out it is something squared minus something squared. You end up with a plus and a minus binomial. So I'm going to show you how this works. So the generic version, since I can't draw squares like that, is using a's and b's. So it's an a squared, something squared, minus b squared, something squared, and we end up with a plus and a minus binomial. So let's actually practice that. So x squared minus 25. X squared is just x squared, and 25 is 5 squared. And there's a minus sign in between there. So what we're going to do is we are going to take the two pieces that are inside the parentheses. They are the things that we are squaring. And in the first binomial, I'm going to add them. And in the second binomial, I'm going to subtract them. And that is the factored answer of x squared minus 25. Now, if I was just to double check that really carefully, my parentheses turned into a circle. If I were to check that really quickly, x times x is x squared, x times negative 5 is negative 5x, 5 times x is a positive 5x, and 5 times negative 5 is, whoops, my iPad is having a life of its own right now, is negative 25, and our middle terms add to 0, which is exactly what happens in a difference of two squares, and what we would get is exactly what the original problem was. So let's try another one. It might come in handy if you want to make yourself a list of all of the square terms. If you have your composition notebook, you might have it. Things like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on, because those are the numbers you're going to be looking for. So this is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on. So 4 squared minus 81, sorry, 4x squared. So 4x squared is 2x squared, because 2x times 2x is 4x squared, and 81 is 9 squared, which means that in our two binomials, one being a plus binomial and one being a minus binomial, we are going to have a 2x and a 9. So 2x plus 9 and 2x minus 9. If you were to distribute that, you would get 4x squared minus 81. So that is the factored answer of 4x squared minus 81. Now, number 3. 18 is not a square term. 8 is not a square term either. 8's a cube term, but that's a different problem. But what I want you to remember is at the very top of our factoring flowchart is the GCF. You always have to ask yourself first before you do anything, is there a GCF? On this problem, the answer is yes, it's a 2. I can factor out a 2 from both of those terms, getting me a 9x squared minus a 4. Now, inside the parentheses, I have 2 terms going through the factoring flowchart, and I have to say, okay, is it a difference of 2 squares? So 9x squared is 3x squared, and 4 is 2 squared. So yes, it is. So in our answer, do not forget your GCF. GCF is part of your answer. And we have 3x plus 2 and 3x minus 2. I also want to mention, if your plus and minus is backwards, so if you had your GCF of 2 and then you had 3x minus 2 and then 3x plus 2, those are the same answer because you can multiply in any order.